morning, my name is Mahinder from EC Department, Vigyan Institute of Technology and Science. Now we are going to do microwave engineering lab experiment. Today our experiment is scattering parameters of E-plane T. The main aim of this experiment is to study the parameters of E-plane T and determine the S parameters, scattering parameters of E-plane T. For this experiment we required apertures is first main one is the Klystron power supply and Klystron mount with tube, isolator, frequency meter, variable attenuator, detector mount, and main one thing is the E-plane T, match termination, CRO and PNC cable. Diagram here I have drawn the block diagram. The first one is Klystron power supply connected to the Klystron mount with tube. It is connected to the isolator and it connected to the variable attenuator and frequency meter and E-plane T. Here we are using a match termination to terminate the port, and finally we got output from the detector mount. The output we can see in CRO. Okay. First the Klystron power supply gives to the Klystron mount to generate the microwaves. The microwaves passes to the isolator. Isolator using for isolate the power. It transmit only one direction power supply. Variable attenuator using to attenuate the power. Here we can calculate the frequency by using frequency meter. Here the main component E-plane T. By using E-plane T, we are determining the S parameters. Okay. Coming to the structure of E-plane T. Here E-plane T, this is called E-plane T. This is the rectangular waveguide. The broad side we are cutting and pasting the one waveguide by horizontally, vertically. So it's called as E-plane T. Here E-plane T have three ports. One is port 1, port 2, port 3. The vertical arm is called as E arm. Okay. When we are applying the microwave powers to the port 3, it is port 1 and it is port 2. When applying the microwaves here the power will be divided equally, but in 180 degree phase shift. Here we can see here the direction of microwaves is up direction. Here the port 2 is downward direction. That's why we can write as property of E-plane is S13 is equals to minus S23, because it is the input, we are getting output, here input, here output, because of 180 degree phase shift to perform determine the S parameter. Okay, actually we can write the S parameters by 3 by 3 matrix, because we are using the E-plane T, that is 3-port network. So we can write the S matrix as 3 by 3 matrix. Okay, that the S matrix is S11, S12, S13, S21, S22, S23, S31, S32, S33. Why are writing as S11? If we are giving the input to second port, we will get output at first port. That's why we are writing as S12. Okay, as far we are writing the S matrix. Now we are going to perform calculate the properties. What is the properties that they? By using the properties we can derive the S matrix. Okay, first property is, as for the E-plane property, S23 is equals to minus S13. Why? When we are applying the voltage, applying the microwave source from port 3, the power will be equally divided between port 1 and port 2, but it pays a phase shift of 180 degrees. So the 180 degree phase shift we can write as the minus negative. That is S23 is equals to minus S13. And here the port 3 is perfectly matched. So we can write S33 is equal to 0. Why we are taking S33 is equal to 0? If applying the voltage power from 4 to 3, here the reflection of the microwaves is 0. So that's why we are taking S is equal to 0. Okay. As per the symmetric property, Sij is equals to Sji. So we can write S12 is equals to S21, S13 is equal to S31, S23 is equal to S32. Okay. Now we are going to substitute all the values in S matrix. So we can write S11 as is S2 is equal to S2, S12, S13 as is. Here S21 we can write as S12 by using symmetric property. S12 is equal to S21. Here S22. Here S23 we can write minus S13 by using the E-plane properties. Okay. Here we can write S31 to S13 and S32 is equals to, we can write S1 minus S13. Here 0. S33 is equals to 0 as per the perfectly matched condition. Now as per the unitary property, we can write S conjugate of S is equals to I. Here the S conjugate of S of I, we can apply S scattering parameter of S and conjugate of S parameter equal to unitary matrix. Okay, now we are going to multiply the matrix. So first we are taking R1 C1. It is R1 C1 conjugate of S1 square modulo of S1 square modulo of S12 square plus modulo of S13 square equal to 1 and R2 C2 equals to modulo S1 square plus modulo of S22 square plus modulo of S13 square equal to 1. As this R3 C3 is equals to modulo of S13 square plus S13 square equal to 1. Now we can take one more value, that is C1 R1 C3. Sorry, R3 C1. R3 C1 equals to, we can write as S13 of conjugate of S11 minus S13 of S12 equals to 0, because we can take 0 into S13 equals 0. Okay, we got four equation: equation 1, equation number 2, equation number 3, equation number 4. Here the equation number from equation 3 we can write as S13 equals to 1 by 2. How we get? It is S13 square plus S13 square is equal to 1. We can write as 2 into S13 square is equals to 1. That's why from here we can write S13 is equals to 1 by root 2. From equation 4, we are writing, we are common the S13 term, S13 of S11 minus S12 equals to 0. It will be equals zeros. So S11 is equals to S12. Now we are going to subtract RC1 minus RC2. The common terms will be related. S12 cancel. S13 square cancel. So we can write S11 square minus S22 square equals to 0. So we can write as S11 equal to S22. Okay, we got S11 S11 equal to S12, S11 is equal to S22. So we can write as S11 is equals to S12 is equals to S22. Okay. Now we are going to apply this value to any one equation so that we can find out the any one values. So I am going to substitute the values in our first equation. Okay. S11 square, instead of S12 I am writing S11. S11 square. We know the S13 value, so we can write as 1 by root 2. Whole square of 1 by root is equal to 1 by 2 equal to 1. Now we can write as 2S11 square equal to, the 1 by 2 is goes on other side, it will be 1 by 2. We can write as S11 is equals to 1 by 2. Now we can write as 1 by 2. Okay, we got all values. S11 is equal to S12 is equals to S22 equal to 1 by 2. We got all values. We are going to substitute values in S matrix. The S11 value is 1 by 2. S12 value is 1 by 2. S13 equals to root 1 by root 2. S12 is equals to 1 by 2. S22 is equal to 1 by 2. Minus S13 is equals to minus 1 by root 2. Here S13 is equals to 1 by root 2. Minus S13 is equals to minus 1 by root 2. And S33 is equal to 0. This is the value we are got from the symmetric properties and S parameters, S matrix. The values are we can do in experiments, in practical also. We have to get these values from experiment. Now we are going to do lab session, same experiment in practicals. To the practical session, this is called E-plane T. This is the 3-port network, port 1, port 2, port 3. The vertical, the waveguide is connected to the vertical waveguide, so it is called the E-plane T. It is the port 1, port 2, port 3. As we discussed in the earlier lecture, when we are giving the input to the microwave signals to the port 3, the power will be divided equally between 1 and 2 with phase. Okay, that's why now we are going to do the practice session. You will see. Now we are going to switch on the power. Observe that the power current will be increasing gradually. Here we have to obtain the maximum square wave input, then we can take it as a input voltage. We have to keep the beam voltage at least 235 volts. And the reference voltage should be in maximum position. The modulation section should be in AM position. Okay, now we are going to adjust the reference voltage to get the maximum square wave input. Okay, observe the output, input voltage. When I adjust the reference voltage at 201, we got the maximum square wave input. The square wave input we can take as the input voltage. Note down the voltage. Okay. Without connecting the E-plane T, we get the V1 After connecting the E-plane T, we have to find out the scattering parameters. That is S12, S11, S12, S13 and S21, S22, S23, S31, S32, S33. So instead of taking all values, we can take it as only S11, S12, S13. Because as per your derived scattering matrix, we want only one S13, S11, S12, S13. Okay. Now I am going to connect the E-plane T. Okay. Now we are connected the E-plane T. Here the port we are connected input at port 3. We are now going to measure the output voltage at port 1 as well as port 2. Okay, even we can take one value, that will be enough for us. Okay, observe the values. What is the input we got, output we got? It is almost 1.8 millivolts. That is 80 millivolts. Now we are going to connect at the port 3. We got, earlier we got S13. Now we are going to calculate S23. The same value we can get S13 is equal to S23. We got S13 as 15. V2 value is 15 and V2 value, V3 also we got 15. We connected the input at port 1. We are observing the output at port 2. The port 3 is matched with match termination. Observe that the value, the output value is almost 15. Not the value of 15. Okay, as well as we can connect the input at port 2 and observe the output at port 1. Okay. Okay, here we are taking the beam voltage is 235 volts and beam current is 19 milliamps. The input voltage is 15 millivolts. As connecting the E-plane T, we got the output input at the port 3 and output we got 15 millivolts at port 1 and 15 millivolts at port 1. As well as we connected port 1 input at port 1. We got the output voltage at port 2 is 50 millivolts and output at port 3 is equal to 0. Okay. As well as we are going to observe the values and compare the theoretical value and practical value. Now we are going to do the comparison observation. Okay. Observation. We connect the E-plane T at port 3. The input voltage is 28 millivolts. At port 1 we got the voltage 15 millivolts. As well as port 2 the output voltage is 15 millivolts. After connecting the port 1 we got the input is 28 millivolts. Output at port 2 15 millivolts at port 2 and at port 3 we got 15 millivolts. Another port, the port 2 we connect the input. The V2 is input voltage is 28 millivolts. By using this value we can derive the scattering parameters. First we are going to do the S12. This is the input, this is the output. The input is 28. We got output at port 1 is 15. So we can write 15 by 28. It is approximately 0.53. As it is S13 input by output, we can write as 0.53. Here S11 is equals, we are taking 0 because we can't take by connecting the input we can't take output at the same port, so we can take that S11 is equals 0 as well as S22 is equal 0 and S33 is equal 0. Okay, after taking the values we can write the scattering parameters. S11 is equals 0, S12 is equals to 0.53 and S13 is equals to 0.53 and S12 also 0.53, S22 is equal to 0, 0.53, 0.53, 0.53, 0. Compared to the theoretical value and practical value, here we got approximately values. Here 1 by 2, 0, 1 by 2 is nearby 1 by 2, it is 0.53. Root 2 by root 1 by root 2 is equals to approximately equal to 0.53. As it is, we got the approximate value. Okay, we are obtained the scattering parameters of E plane successfully. Okay, thank you.